this is 2021 AA, Thompson 1, paper 2, SL. Alright. And this video is on the solution of section B. If you need section A, link is in the description below. If you want to take screenshot of the questions, you can do it now. This is 7. This is 8. This is 8 continued. And then this is 9. And 9 continued. Alright, again, highly encourage you to try them before you watch the solution. After all, there's not that many past paper for the new syllabus. But 7 is a compound interest sequence kind of question. People want to save. They have 9,000 to start with. Somebody do compound interest. There is a compound interest formula in the formula booklet. So let's show you how to use it. So it's like here. Okay, FV stands for future value. That's what you get at the end. How much you get at the end. So for I, the question is how much you get after 5 years. So you're looking for the future value. Future value equals to PV. PV is present value. Do you see what I'm looking at? It's this one, okay? This is the formula for compound interest. PV is present value, which means how much money you started with your investment. So it's 9,000. Okay, times 1 plus out. Out is the interest rate, so it's 7. Alright, you would think you probably use 7%, which you do. 7% is 7 over 100. So that's why in the formula there's 100 in the bottom. Yeah, kind of weird notation. Then you have n in the power. N is the number of years for your investment, so it's 5. Alright, and then there is k. K is how many times do you compound in a year? Okay, how many times you compound in a year? This question, they're compounding it annually, which means you compound it 1 times per year. So k is 1. Alright, so this would be it. Okay, so this is where you just use a calculator. So I guess for completeness, I'll do it. So we got about this much. Oh, they want the nearest 100. So you should do the nearest 100. So the question is, how many years do you need to do it? So you're looking for n. Right, so it's basically the same formula, except you change the 5 into an n. And her target is to get $20,000. Alright, so again, we use a graph to solve this. It's not like we'll do it ourselves. So the first function is 20,000. Second function is 9,000 times bracket 1107 to the power of n, which we use x here. So we plot it. There's an intersection, which we will need to find. 11.82. So it basically takes 12 years, right? I guess. Does it mean take 12? Let's say you take 12. I mean, you can watch my last year solution. I also get this wrong all the time. So, because I be just think of these things really not very consistent. Maybe there is somewhat consistent, but I can't really get the logic. So I would suggest you actually write down the actual value and then say what you think the actual number of year would be. I think it's 12 because 11 is not enough. right? By the 11th year, you don't get enough because it takes a little bit more than 11th year. So in some sense, it will take you 12 years. Okay, so compound interest, not bad, right? Then second guy do the same, but his thing is compounded monthly. So it means K is 12 because you compound 12 times in a year. What would be the R so that he can get the money in 10 years? Alright. So you probably expect R to be quite smaller than 7. Remember, 7% took 12 years, as we've seen, if you compound it yearly. So the idea is if you compound it more frequently, you get slightly more. Alright, so you kind of use the same equation. So 20,900 1 plus R over 100. We're looking for R. K is 12. And they want to do in 10 years, so N is 10. Again, this is GDC. So this question, even for N standard, is quite easy to most of you. 7 over 1,000 times 12, so 1200 to the power of 12 times 10. Right, that's the unknown we're looking for. So it is X. Okay, so we plot it. Yeah, plot. There's the intersection. Oh, come on. There's the intersection 8.0117. Oh, that's the R, right? Interest rate is okay to be decimal. So R is 8.01. So the minimum value of R is 8.01 in 3 significant figure. Okay. Then C. You know, the meme which talk about how math didn't teach you how to do taxes or plan for your retirement, that kind of thing. I think I said this joke in a previous paper. Well, this question is teaching you that. This question is teaching you the power of compound interest. Right? You can see if you put your money into the bank with 7% interest rate for basically 12 years, you can save. If you start with 9,000, you get 20,000, more than doubled. At this moment, it's not easy to find a bank that gives you 7%, but something close should be possible. But C, the third friend, is not using the power of compound interest. Alright, his plan is to put it into a safe where there's no interest, but what he'll do is actually put in more money every year. Alright, interestingly, instead of putting more and more, he put half of what he put in the previous year. Alright, the sad thing is, by doing this, he will never reach his goal of 20,000. Alright, so this is like why compound interest is so good. Because you just set up your initial investment, then it's supposed to be growing on its own almost. If instead you try to like save up actual amount without using the power of compound interest, it'll be quite difficult. In this case, he will never get it. So you may want to try to see what he's actually doing to get a feeling of the question. So he'll start by 9,000. Then the next year he'll add half of that. So that's what, 4,500. Then the next year it would add half of that, which is what, 2,250. Okay, then now you probably realize this is a geometric sequence or geometric series because we're adding them up. Okay, then you think, why would he never reach the target? Alright, what's the question mean by never? Well, it means even if you keep doing it forever, you'll never get 20,000. So it seems to be something to do with sum to infinity. Which is, of course, in the formula booklet. If you have the old version of the formula booklet, they will tell you the sum to infinity formula is u squared over r minus 1. This is actually a typo. IB soon corrected it. However, some website still use the old wrong version. So that might mess you up. Alright, so the actual formula is u1 over 1 minus r. So the first term is 9,000. R should be obvious, u times half. Then if you press the calculator, you get 18,000. That's why you never get. Alright, so that's then that. That's why you never get 20,000. Then see how much should Chris start with so they can reach the target in 5 years. So it sounds like it's S5. We want to do it 5 times so that the sum would already be 20,000. So if you look at the formula booklet, the formula for geometric series, the sum of geometric series would be u1 times 1 minus r to the power of n over 1 minus r. So u1 is like how much you put in at the beginning, which is what we want. And r would still be half because his plan is still like put half of what he put in the previous year. N is 5 because 5 year 1 minus r, and you need this to equal to 2,000. This is again the job of a GDC. This what u1 is our x times 1 minus 1 over 2 to the power of 5, 1 over 2, ouch, to the power of 5, close brackets, over 1 minus 1 over 2, and we need this to equal to 2,000. Okay, plot. So we need to change the axis a little bit. U1 is like money, right? We know it's probably bigger than 9,000, so we'll need quite a bit. Go to what? Maybe 20,000. Y was 20,000, so we need something around that much. 20,000. No, not 2,000. Oh my god, did I put 2,000 before? When I maybe discarded? No. Okay, let's put the correct Y first. It should be, oh yeah, I probably put 1,000. It be like 19,000 to like 21,000. Confirm. I'll have to change, yeah, missing the 0. Let's see that again. Find the intersection. So U1 is 10322.58. So that will be how much he need to start his investment with. So there are 2 fences. So I guess the 2 straight line are the fences. And there's a horse tied to a post, a P, with a rope of length L. Blah blah blah. Distance R. So there's the length of the rope, I guess. Theta is in radian. DE have a the arc DE have a length of 28. So that's the curve bit. Find regular expression for R. Alright, so that's probably using the formula for the arc length. So if you check the formula booklet, the arc length formula is radian radius. Alright, the thing about this formula is it only works in radian. So this theta has to be in radian. Okay, so the arc length is 28, so this is equal to 28. They want R in terms of theta. That means they want R to be the subject, so it's 28 over theta. Right, just divide it away. And they want us to find the area of the field that the horse can reach, so it's probably this whole thing. Alright, so we want to find the area of that. So we'll probably do the area of this sector plus the area of this triangle. Okay, so the sector, we have a similar formula. It's half radian radius square. Again, this only work for radian. For the triangle, we use half AB sine C. AB sine C, where A, B are two lengths, and C is the angle between the two lengths. So we have the two lengths, the two R, so it's R times sine the angle included by the two sides, so this is angle. So this is theta, so this should be, 180 minus theta, except we're using radian, so pi minus theta. And the sector, well, it's basically this, because radius is r and theta is theta. And then r times r is r squared. Now the key of this question would be knowing how to simplify sine pi minus theta. So these go back to the unit circle thing about trigonometry. So the idea is 180 minus theta is in quadrant 2. And in quadrant 2, psi is positive. Therefore, sine 180 minus theta would equal to positive sine theta. Okay. You check out my lecture on unit circle if you want to fully understand it. But if exam is this close and you don't really mind, you can just accept this. Well, so the area that the horse can go would basically be the sum of them. So it's this plus this. So we can factor out half, and we can factor out the r square. So it's theta plus sine theta. Now you can see there's no r in the question, like in the answer that they want. That's because they put in the r we found. So it's half, r is 28 over theta squared. So 28 squared is what? So 28 squared, and then there's a half, so we divided by 2, so it's 392 over this theta is also squared, theta squared, like this. Okay, that's what they want, right? I mean, it's 392, yeah, I copied it wrong. Turn out the area is actually 460, so what's theta? Well, we just make this equal to 460, and then it's GDC time. So I should type 392 divided by x squared times, times x plus sine x. What am I doing? X plus sine x. Okay, and we want that to be 640. And then we look for the intersection. They don't seem to want to intersect, so I think I'll have to do the x's myself. So x is an angle in radians, so it's probably between 0 to 2 pi. And y is roughly 640, so that should do. And find the intersection. So theta is 1.439 radian. All right. Then knowing theta, hence find angle DAE. So this one. So the key would be now we know theta, and if we know theta, since angle of a line is 180 or pi, we'll know that one. And also PA is R, PB is also R, so this is an isosceles triangle. So whatever this is would be the same as this. Hence, it should be quite easy to get angle A. So obviously angle APE would be 180 in radian is pi minus the theta we got. So it's 1.439. And then angle DAE would be pi minus APE divided by 2 because those two angles are the same. It's again pi minus because the angle sum of a triangle is also 180. So you can press the calculator to get that. You should get 1.439 divided by 2. So it's 0.7195. Okay, then the question continue. A new fence is to be constructed. I think the diagram is quite unrelated. For example, the owl is completely gone. Yeah, it was D and E here, but now it's changed to C and B, so I think they're unrelated. The only thing that's left, the only information that is carried over is that this angle was just found to be 0.7195 in radian. Then we have something of length 800 here. And then we're given that the bearing of B from A is 195 degree. So the question is suddenly changed to degree. It's quite, I mean, it's extremely rare that bearings is given in radian. So change radian to degree times 180 divided by pi. So this is actually 41.22 degree. The bearing of B from A is 195. That means if you go to the cross at A, you go from the north clockwise 195. And that would go to B. Also, C is east of B. That means if you put a cross at B, this would be exactly 90 because C is on the west of B. Our goal is to find angle ABC. Okay, so it's probably this little bit plus 90. Alright, here is the key of bearing. In bearing, all the north line are parallel to each other. So this is parallel to this. Alright, therefore we have something like this, where these two lines is parallel. Then due to alternate angle, these two angles are the same. Right. So we know that this little bit is the same as that little bit. And this little bit is obviously 195 minus 180 because a straight line is 180. So this is 15 degree. So that's also 15 degree. So ABC will be 90 plus 15. So it's 105. Alright, then the question is, what's the new fence required? So it's here. So this should be sine rule or cosine rule. So the key is noticing that in a triangle we have two angles involved. We know two of the angle. We know this to be 41.22, and also we know the 105. So if you have two angles involved, you use sine rule. Alright, so sine rule go like this. We usually only use two at a time, where small letters are length, capital letter are angle, and also like A is opposite to A, B is opposite to B, so on and so forth. So which side do we have? We have 800 would be opposite to sine. The opposite angle of 800 is 105. So B is what we want to find. Alright, so the fancy is B over sine the opposite angle, which is 41.22. Alright, then we multiply the bottom to the other side, so B will be 800 times sine 41.22 over sine 105, which come out to be, okay, we should be careful that we need to change it to degree because now we are suddenly using degree. So it is 800 times sine 41.22 and then over sine 105. Get 555.76. That should be the new length of the fans. Question 9. We have some function, and they want to know the intersection of that with another line. Well, that's the specialty of GDCA, I suppose. So it's 90 e negative 0.5 x, and then a line which is just x. So obviously we would have to set the axis. They didn't say much about what kind of window we can use, so we have to guess. So it looked like only the positive side matter. So usually I go like 10, see how that goes. So for y, also from the graph they provide only positive seems to matter. So 10 maybe, 10, 10, see how it goes. Well, it's not as good as what they give us, but good enough, I guess, because I probably find the intersection already. 5.566. Okay, I guess that work. To be sure, maybe I should make this bigger. So maybe go to 50. This also go to 50. That's worse. Maybe 30. I think that's good enough. Then we have L being a tangent, so this is L, a tangent to F at Q, at the point Q, and L have a gradient of -1. Find Q. Okay, so gradient, obviously that means differentiation. So it's a tangent to F, so we need to differentiate F. So coefficient just stays, doesn't do anything. Differentiate E is just E. Then we do chain rule, so times differentiate the inside. Differentiate negative 0.5x, gets negative 0.5. Then we multiply the number. So it's negative 90 times 0.5 is 45. We want to know when is this -1, because the gradient is -1, so we make this -1. Now maybe you want to use the calculator right now, but if you do that, you won't be able to get the exact value. The calculator will only give you an ugly decimal. So that won't be exact. So we have to do this ourselves. We will divide the 45. So 1 over 45. Well, the negative cancel out. So 1 over 45. Then we ln both sides due to the e and the fact that the unknown is on top in the power. Then according to the properties, this can drop to the front. L and E is of course 1. 1 over 45 is more like 45 to the power of -1. I did that because then the -1 can drop. And that would cancel out the -1 on the right. L and E is 1. Cancel out the -1 on the right. 0.5 is really half. So we multiply the 2 to the left. X is 2 ln 45. Okay, that looks pretty exact. coordinates, so I want the y coordinate as well. We'll plug x into the original function. So we get 90 e negative 0.5 x, where x is 2, ln 45. So again, 0.5 is half, cancel off the 2, the minus 1. Well, here to get this value, you need to use the rule e to the power of ln x is just x. Alright, it's kind of in the form of booklet, but if you've never seen this before, you probably don't know that you should look. Now, the idea is like e and ln are inverse function of each other, so they cancel each other out. So kind of like they cancel out to be x. Now the problem is the rule doesn't work when you have some number, or anything at all in front of the log. So we have to bring this back inside as a power, so using that property again. Then the e and ln cancel out, so it's 45 to the power of minus 1. 45 to the power of minus 1 means 1 over 45, 90 over 45 is 2. So the y coordinate is exactly 2. So the coordinate is 2 ln 45 2. That's q. And hence show the equation of L. So we do I equal to mx plus c. M is the gradient. Gradient is minus 1. To find c, we sub in the coordinate. So 2 is y. 2 ln 45 is the x. So c is 2 plus 2 ln 45. That's the equation. ln 45 plus 2. Alright, that's exactly what they have. Then there's an area enclosed by f, the line y equal to x and L. Find the x coordinate of the point where L intersect y equal to x. Okay, so that will be another GDC work. Look like I should add the third line, which is negative x plus 2 ln 45 plus 2. So kind of one there. So look like I should like zoom in there. Maybe the y is too much. Let's see. But okay, that's better. That's a bit better. The scale is a bit off. Right, the graph is a bit squish, but it's good enough. We want the intersection between L and y equal to x. So we will find intersection. I believe is the green one and the blue one, so it's 4.8066662. Okay, for IB usually you can write more. The idea is we need to find the area of A. Now notice we know all these 3 points. We know this point, which is an intersection between L and the line, so it's 4.806. We know P. P was here, so P is 5.566, and for Q is 2 log 45. It's Q. We know all 3 points. So turn out to find this area, you have to cut the area into 2 parts. Precisely, you cut at P. Okay, because if you cut it like this, you realize the left-hand side of this region is formed by y equal to x and L. Alright, y equal to x is on top, x is below. while for the right hand side is F on top and L below. And whenever your area is formed like this with an upper curve and a lower curve between two different x values, you want to integrate the upper curve minus the lower curve. Okay, so for the left hand side, the upper curve is x minus the lower curve is L. L has the equation that, right? So it's negative x plus 2 ln 45 plus 2, we missed the plus 2, plus 2 dx. So for that part, it will be between this is too thick, 4.806 to 5.566, while for the right of the region, the upper curve is f. F is what? 90 e negative 0.5x minus L 45 plus 2. Alright, from 5.566 to 2 ln 45, okay? Because this is the cutoff point. Alright, then you will basically type this whole thing into your GDC to find the area. Now, one way would be you go outside to where you do math and you type the whole thing in. Sometimes the calculator can do it, the lower bound. Lower is 4.807, okay. Upper bound. My calculator only do one curved, cannot do area between two, so I suppose. So it's not very helpful. Alright, I'm kind of not in the mood of typing, so whatever that is. Then you have what? Then you suddenly have the inverse of f. So this is the inverse of f. This one that they drawn there. That's the inverse of f. We are to find the area of this whole thing. Now, obviously, to draw the graph of the inverse, you reflect the original f along the line y to x. So that's why it was there, and like they're trying to hide that. Well, actually, just say here. Somehow, I don't know why that line is missing. All right, and f inverse is the reflection of f along the line y to x. So it should be quite clear that this red area was the reflection of the area we just found. Alright, so the total area is simply what we found before in part D, I, and then times 2. Alright, whatever that was, times 2, that will be the answer. Okay, you get 2 marks for realizing their reflection of each other. Now that will be the end of this paper. I hope this helped you a little bit. I will still be doing times on 2, so if you're interested, subscribe would be nice. Otherwise, just stay tuned on my channel, and hope to see you there.